In the earlier lesson, we used the Boolean algebra properties to simplify the expression. So this was one of the example we used. So going through several steps and then applying those properties, we have reduced this equation into this simplified expression. So one of the problem using Boolean algebra properties is the process is quite complex and error prone, and then once you reach at the end, you are not sure 100% assured that whether there is some other properties you may apply so that this could be further reduced, or if you have taken some other properties first, you may get some different result and the like. So you are not 100% assured at the end whether this is the most simplified form or not. But using kmap, you can be assured that you always reach the most simplified form. So let's solve this one using kmap then. So first step, to construct the kmap, we need to know min terms. So min term means each term should have all of three variables appearing. But in this expression, not all three variables are appearing. Then we need to recover that back. How do we recover is based on the idea. Here, z is not shown because it's a z plus a z not is implied, which is 1. So identity in the inverse law, because of that, it's reduced. So xy represents xyz or xyz not. So xy means x is 1, y is 1, and z could be 0 or 1. So two possibilities are there from xy. So in terms of a min-term position, this represents 6, this represents 7. From the second term, x is 0 and then y is gone and the z is 1. So this represents 0, 0, 1 or 0, 1, 0. 1, 1 is a possibility. So here this one could be 0 or 1. So this represents the min-term position 1 and then 3. So finally yz means something and then yz. So y is 1, z is 1 something, y is 1, z is 1, so it could be 0, 1, 1 or 1, 1, 1. So this represents the min-term position 3 and then 7. So this function is actually min-term positions 1, 3, 6, 7. And this 3 and this 7 are already counted. So 1, 3, 6, 7 is the expression for this function. So based on that, let's construct a kmap. So three variable kmap. We have this form, and then x is the first variable, most significant position, and then we have a yz. So heading 0, 0, 0, 1, 1, 1, 1, 0. So 0, 1, 2, 3, 4, 5, 6, 7. So that is the kmap we construct out of that. Then the maximum possible grouping would come this one and this one. So by choosing those two groups, we cover all min-terms. So we don't have to choose another one here. This one is already covered by two blue ones, so we don't have to choose that one. So this first group, the expression is x is not changing, so x not, and between the two y changes but z remains. For this one, x with a value of 1 not changing, but between two adjacent ones, y is 1 and not changing, z changes. So the result, the simplified expression is x not z and yx. So you have the conclusion here. So as you can see, using kmap, you are assured that you reach the most simplified solution. So that's the benefit of using systematic mechanism called the